actual state of the cluster, and the controller basically tries to reconcile both of these all the time, right? So these two variables we need to codify in our Golang controller. So if you see the struct here, the Acme namespace spec struct, right? It has two string variables. One is the namespace name, and another is admin username, right? So in a way, we have created a model for our controller, right? So just like in a web application, you would have a model for the data that you want to capture, store, update, retrieve. Similarly, you basically create a model here of your CRD that you want to create, and based on this Golang, your cube builder will have. So cube builder provides you a boilerplate which does a bunch of things, right? It gives you sample Golang code, like for example, this it will give you a sample. What do you say? Manifest for your example, right? And it will have multiple make. It will also create a make file for you. So when you run the make file with this particular build target, it will create the final. It will generate the CRD based on this information, right? Next is the logical implementation, which is so once you've defined the data, you go ahead and start working on building your controller, right? So like we said, a controller is it's a piece of code which is running in your cluster, perhaps as a pod, which will keep a watch on these resources that you want to deal with. And again, Cube Builder kind of makes it pretty straightforward to create a sample controller of sorts, which would kind of keep a watch on a particular resource that you want to create and define, right? Uh, okay, so let's talk about existing state. So like you said, there's an existing state and there's a desired state, right? And the controller kind of reconciles the both. So how do you know the existing state of a particular resource? You would know that from the status of your custom resource. So if you run kubectl, let's say if you get a YAML of any existing resource in your cluster, you would see that in the YAML you have a status section and you have a spec section, right? Okay, it's too long. Okay, so this is the spec section, and there is metadata, right? So there's metadata, spec, and status. So the existing state of a resource is can be derived from the status section, right? So this is the status for a pod. I think we'll take a smaller example instead of pod. If you check a namespace, yeah, this makes it clear. So you have metadata, you have spec, and you have status. So in the status, you can say that the phase of this particular namespace, this object is active, right? This is the current state. Coming back to a book, yeah, so Kubernetes uses a status.phase field on resources to keep a track of what is the actual status of this particular resource. So for example, in case of pod, you would have running, you would have active, you would have pending, you know, uh, and similarly for namespaces, you would have active, you would have deleting, you would have deleted, and so on, right? Uh, Next, a controller cannot assume that it is a new resource and just vertically. Okay, so let's look at the code first, and we'll jump back here. Once we see the code, I think this will make more sense, right? Because this is less to do about Kubernetes, but I think this section is more to do about good practices of programming and making sure that your controller is idempotent in ways, right? So, for example, if I just summarize this section, if you create a controller, like we discussed, right? So, Acme namespace controller, and once you submit that, a bunch of sub resources should be created. Now, very first time when you submit this code, that's fine because nothing exists, right? And it will go ahead and create those three resources. But when you, let's say, make a change to that resource or your controller kind of restarts for some reason, then the API server will return an error by default, right? Because if a namespace exists and you go and try to create the namespace again, it is going to fail, right? So it's about adding those checks and balances in your controller so that your controller kind of becomes idempotent, and it will ensure that it does nothing if nothing has to be done, and if it does something if something has to be done, right? So it's more about programming and less about Kubernetes per se. But let's go to the code. Uh, what's the code? Okay, here's where the code starts. Okay, this again is a boilerplate code that Cube Builder is supposed going to provide for you. And what we are focusing right now is the reconcile function inside this boilerplate, right? Because that's where the logic is. So what happens here is you start with basically declaring a variable. We call it acme_ns here, and we will kind of fetch the namespace, the new object that we've received inside this variable, right? So and we extract the two uh, what is it? Yeah, the two variables that we had in our YAML, we extract that inside this code, right? So one was the name of the namespace that is to be created, and another was the name of the admin user for that namespace, right? So we extract this data from that object, and then we go ahead and create a namespace object, right? Because obviously we want to create a namespace first, right? So this is an object that would, in a way, map to a namespace, which is going to be submitted to the cluster here. When you say r.create and you submit this namespace object, this will send an API request to your API server with this metadata, right? Where we have a label where admin name is admin and the name of the namespace is ns name, right? So these are the two variables that we have extracted here, right? Ns name and admin user, which was extracted from our custom resource, right? This is just for the namespace section, but if you go down, you also want to create a role and a role binding, right? So just like we created a namespace object and in a way kind of templatized, evaluated the template here. The same thing we do for a role and a role binding, right? So this is your Golang code, which will do nothing but create a namespace, a role, and a role binding when you submit this. But as we discussed, I mean, this is good if you're creating it for the first time. But if you want to make any changes or if your controller restart, this is going to fail, right? Uh, does that make sense? Am I going too fast or I don't know? Okay, all right,
It is good. Okay.
cool. So just to reiterate, right? So what is going to fail here on the second run is this particular line. If you see here, right? So when you say create something, and if that something already exists, API server is going to fail, right? That is what the catch here. And in the later section, we will make use of the status phase that we discussed, right? The phase of the particular resource and add nothing but a switch case, right? So if you go down, right? So in the earlier section, we had seen that we defined two variables in the Acme namespace spec section struct, but here we add a new variable in the status struct, right? So we are now adding this status to our custom resource, right? And we are calling it phase, right? So it is status dot phase. And to leverage that in the same controller code reconcile function, right? So in the earlier reconcile function, we directly started with creating of the resources, but here you see that there is a switch case introduced, right? So there are certain scenarios that are predefined based on the phase, right? Status phase. So first thing is uh, it might the phase might be in created state, right? You might have already created whatever sub resources you want to create for your custom resource, and your status phase might be created. And in that case, you basically do nothing, and you just log a line saying that everything has been created because I've verified the status. Second, it could be in progress, right? So, for example, when you submit this new CRD to Cube API, it goes ahead and creates a namespace, and then it is supposed to create roles and role bindings, but it crashes before that, right? So only namespace is created, but role and role binding are not created, right? So in that case, your status should be in progress, right? It is basically trying to do whatever needs to be done, but it has not completed all the steps, right? And in the third case, I mean, it could be blank. Your status could be blank. So when it is blank, you directly go ahead and set your phase in progress to start with, right? Once you do that, you go ahead and then start creating the resources, right? So in this case, it is a snippet, right? So here you would have to basically replace whatever we saw earlier, right? Create namespace, create role binding. And if all of this is successful, you go ahead and then update the state to status created, right? Again, I mean, it's more of programming, less of Kubernetes here. So you just introduce a switch case, you watch the status, and based on the status, you perform actions, right? so that your controller becomes fail proof in a way.
So one
Okay.
question, I don't know whether because I was offline for a while
Mhm.
because of my thing. So just is there any case covered when something fails? How does it roll back? Anything like that has been given here? Is there like, for
Mm.
example, a condition? I don't know if it can come, right. For example, if or I think it will not roll up because I think Kubernetes is going to make sure that status is achieved. It will kind of try to achieve it again, I believe, right? So,
So in this section, they don't talk about rollback, but if you see in this case where, let's say your CRD is stuck in progress, it
mm-hmm.
just says that you can have your own custom logic to do the reconciliation, right? So for
Mm-hmm.
example, if namespace is created but role and role binding are not created,
Uh-huh.
you might have your custom logic here that okay, fine, now namespace is done. Let me resume doing whatever next needs to be done, right? So it can be any custom logic that you introduce here. So I think that part is left to the reader here.
Mm-hmm. Okay. But what I was coming to what I was thinking is, let's say there are 5 steps, right? And 3 steps are being done, right? And now,
Mhm.
if something is wrong in the fourth step, it is not able to perform, right?
Mhm.
Now, I may want to kind of either continue like as a Kubernetes thing, I'll keep waiting, like a declarative method, right? I'll try to
Mhm.
continuously try again and again, 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 right?
Right.
Or I can say that, okay, now if I have tried for 5 times, I may want
Mhm.
to revert back the initial 3 changes and give a failure thing.
Hmm.
So
No, I think
anyway,
that again would be in your custom logic of your status in progress because what you said is mentioned here that a controller will by default try infinite number of times,
okay,
right?
infinite, okay,
And
that's
I
going to be.
Yeah, so and I guess they've not shown how, but
Okay,
it is mentioned that you can have an exponential kind of back off,
okay,
right? Where
understood,
like
understood.
1 second, 3 second, 5 second, then eventually it will go up to 5 minutes and then keep trying every 5 minutes. It
Okay,
stops at
understood.
5 minutes, right? So that is in a way controllable. So what you said could be kind of program, right? So you can also keep a counter that
Hmm.
I've tried it 5 times, it is not working. Now I want to like delete everything, all the sub resources which were created, and then maybe we can have a custom phase which says, roll back
Hmm. Right, right.
instead of just, in progress and created, we can have another option here in the init.
Understood.
Yeah. Okay. Uh, so that's about, okay, we've discussed this. Yes. Okay, so the next section is about setting ownership of the child resources that are created. Uh, this is more for garbage collection purpose of sorts, right? So in this case, when we create namespace, roles, quotas, and whatnot for a custom Acme namespace, when I delete this Acme namespace object, if I set a parent-child relation between these resources, uh, whenever I delete this Acme namespace, all the child objects will also be deleted for me, right? Irrespective of whether the controller is running or not, right? This again would depend on your use case. I don't think in every case for every sub resource that you create, you might want a parent-child relationship, but it's a good practice if you kind of go this way, so that you don't really have any stale resources pending or any orphan resources in your cluster at a later stage, and then you have to do manual cleanups and whatnot, right? So to set that parent-child relationship, uh, okay, there's one more mention here about scoping, right? So APIs in Kubernetes are scoped. You are either namespace or you are cluster scope, right? So it's you either have a namespace scope or you have a cluster scope. So the namespace object itself cannot be under a namespace scope. It has to be in a cluster scope, right? So nodes, for example, are cluster scope. PVs are cluster scope, but pods are namespace scope, right? So a pod can belong to a namespace, but a namespace cannot belong to a namespace. I think there is a hierarchical namespace sig which goes on where you have this option to create namespace inside namespaces, but by default you don't have that option, right? So
Also,
for
this
that to
book,
work,
this book was done a bit old, right? So I think maybe at the point of time that concept was not there, they not covered it here.
Maybe, yeah. Again, I think the hierarchical namespaces is still not part of default. Your offering of Kubernetes. It's still a separate project from last I know. But
No, I don't think so. It is part of it.
is it? I don't know.
I think so.
Maybe let's check.
Because I remember writing a blog about it. At least my team member was writing a blog about it. So
Something wrong with my keyboard. Okay.
about Kubernetes. It's been long, I think.
kubectl HNS. So this command should work, right? In my cluster, if I just do.
There's a plugin actually. It's a plugin.
Acha,
So,
I'll have to
so
install
it
this
will
one
install the
first.
plugin and then it will work. But
Hmm.
I believe it is part of it. That is what I recall.
Interesting. Okay. So coming back to the code, you can just change the scope of this particular CRD from namespace to cluster by adding this particular line here. Uh, it's a comment, but in a way, your kube builder will parse it, right? And you run your make target. It will create a CRD, which is also shared below. Yeah. So the scope of this particular object is kind of cluster and not namespace, right? So once you do that, you want to set the parent-child relationship. Now again, coming back to the reconcile function, which is the same function that we have. Uh, in this, they've added one more uh, logic here in this code, which I didn't really understand uh, why this was needed and how this works, because they say that before they kind of check whether the resource exists on the cluster or not, right? And if it does not, it just says that resource deleted and it kind of exits. But what if the resource is being created for the first time? I'm not sure. In that case, how would this work? So this is something that I still want to kind of go deeper into. Uh, but yeah, that's for later. Coming to the parent-child relationship, this is how you would set your relationship with the parent, right? So before you go ahead and create a particular resource, for example, you define the namespace object, and here you create the object. You would just want to set a controller reference saying that this new object is kind of a child of Acme namespace parent object, right? And you do this for all the sub resources that you create. So this is for your namespace. This would be for the role that you create, and finally for your role binding as well, for your role binding, right? So once you do this, when you delete your Acme namespace object, all these child namespace objects will also get deleted in turn, right? Uh, Next, okay. So next we talk about admission webhook. So there might be cases where the CRD itself would not be sufficient for you to kind of capture all the requirement that you have. For example, in this case, we take a username, right? You might want to validate this username with your identity provider to ensure that whether it's a valid username or not, whether this user has a particular level of access or not, right? So you can also add that logic to your controller, right? And Cube Builder would have provided you with a boilerplate of webhook, right? And you can use a validating. You can validate basically anything that you want with a third-party API running either inside your cluster or outside your cluster, right? That, and finally finalizers. So before you delete a resource, there might be a case where you might want to perform some pre-delete operations, right? For example, if you are running a stateful application, and you delete a particular stateful application, you might want to take a backup of the data which is present as part of the pre-delete, and it might take some time. It might not be instantaneous. It might take a few minutes or a few hours even, right? Depending on how much data is there and where you are copying it to. So what you would do is you would just add a finalizer to an object that is created. It is just a string. There's nothing special about this, but you just have to make sure that it is unique for your resource type, right? So whenever Cube API sees that there is a finalizer attached to a particular resource, it will not directly delete that resource. It will just uh, update the deletion timestamp, right? And then again, you go to your reconcile function in Golang, and when you see that the deletion timestamp is updated and there is a finalizer, you add your logic to do whatever pre-delete steps that you have, and then whenever that is done, that is completed successfully, your controller would remove this finalizer from the object, right? And once the finalizer is removed, the API server kind of free to clean this up.
So you remember that there was some issue in between that some of these namespaces which you create, they
Mm-hmm.
did not get removed for some
Mm-hmm.
reason, right? And then there was a workaround that you need to go and run this finalizer on your own. Something like that was there to clean up the
Okay.
resources. Otherwise, so when you see some cases, right, you do a Kubernetes delete namespace and they kind of stuck for a loop, right? They're not getting away for some reason, right?
Mm-hmm.
And now you have to clean them up. I think maybe it's a part of when you upgrade. I don't know when it happened, but there was an issue. And when you basically remove the file, you go and edit the finalizer manually, and then the namespace get removed. So
Okay,
there
so was
was
there a
a
bug or something?
I think so. There was a bug because of some specific condition. It
Mm-hmm.
was getting stuck, and there
Mm.
was no issue. And then this is how people get rid of it actually. So maybe a namespace created with some old version and new. I don't know what is it, but I remember
Yeah.
that I had seen this issue, and then I used this finalizer to clear up my namespaces.
Yeah. So an interesting case happened with like one of my friends, right? So what he did was he accidentally, so they were using Argo CD to manage namespaces, and there was a separate Argo
Mm-hmm.
CD application which had all the namespaces, right, which was managed
Mm-hmm.
separately from your applications. They had to make some change to this Argo CD app which was managing the namespaces, and somehow he deleted the Argo app and
Okay.
selected the prune option, which meant
Okay.
all the namespaces on the cluster, like everything, just, and it's a one-way street, right? Once you
Uh-huh.
trigger a delete resource thing or delete namespace, you can't do a
Correct.
control Z.
Uh-huh.
But some of the namespaces were like stuck in terminating state.
Uh-huh.
They were not being deleted. Most of them were gone. Some were stuck in terminating state. And I think the reason for that was there were a bunch of stateful applications running in these, and there were some PVs which had some finalizers, right?
Mm-hmm.
So we had to manually go and update patch the finalizer for the PVs. Once those PVs got cleaned up, these namespaces also got cleaned up automatically.
Right, right, right.
But yeah, I
Something.
mean, having these finalizers is good, but the damage had been done. I mean, you can't just expect to have the PV and then suddenly bring another application on top of it and expect it to run, right? So there are a lot of configurations that are usually required. So they had Zookeeper, they had Elasticsearch and whatnot running, and luckily it was a dev
Oh.
environment for them, not a production environment. Prod, if it would have been prod, I mean, yeah, uh, you would have had to say goodbye.
Yeah.
But even the dev was big. There were like more than 100 namespaces, right? So it was
Mm-hmm.
a huge, huge
But
setup.
Dev is still Dev. It's okay.
And dev is still dev. Yeah, I mean, lucky for him.
Yeah, yeah, correct.
Yeah, cool. So next, I think operator part is covered and completed here. Uh, in the next section, we talk about extending the scheduler component of the cluster. Right, scheduler is again one of the core components which determines which node your pod will go into, right? So the scheduler controller keeps a watch on the pod resource whenever there's a new request for a pod resource. Uh, it uses something called as priorities and predicates, right? So it's a two-step process. In the first step, uh, the scheduler will basically filter out all the nodes which are ineligible, or rather you can say which are eligible, right? So if you have, let's say, 20 nodes attached to your cluster, and four of them do not have any allocatable CPU, right? So they are out of question. Let's say three don't have allocatable memory, they are out of question. And by allocatable, it would check the CPU request section for the new pod, right? So if a pod is requesting one core and the and three nodes do not have one core free, they are out of question. You cannot schedule on that. If it requires 4 GB and there are four nodes which do not have 4 GB free RAM, so they are out of question, right? So it starts filtering in the first step. And let's say there are three nodes which are remaining, which kind of meet the criteria that a pod requires. Then it would filter the nodes, or rather sort the nodes, not filter, sort the nodes based on priorities,
Hmm.
right? So again, there are some preset defined priority sorting methods which it has, right? So for example, if you are deploying Nginx, uh, it will look for nodes which have Nginx image already present, right? One of the checks, right? So if two out of these three nodes have Nginx present, they
Hmm.
get us they get a higher score, right? They get 1 point. Next, it would look for similar pods running which are attached to the same service, right? So if you already have a pod running on a node, and this is another instance of that deployment, it would try not to deploy on the same node. It would try to distribute, try to put it on some other node, right? So after these two steps, uh, usually it will come up with one eligible node. Now, I don't know if it finds more than one eligible node. What it does, it's a round robin or it's a random pick. But I mean, if you have a large cluster, I mean, there are cases where you might find more than one eligible nodes. But I think finally at the end, it would just pick one out of the eligible, list that it gets. But you can kind of also have your own custom logic in this, right? For example, if you so here there's a YAML which they've shared, right? So this is a scheduler policy config YAML, which would not work by default. You might have to make some changes to your control plane, which is mentioned here, right? So you can either place this YAML directly on the control plane, or you can ask your scheduler to read a particular config map from the cluster, right? Once you've set that setting, you can go ahead and apply the config map to your Kubernetes. And here, what we are doing is we are just adding a selection criteria, right? So what we're saying is look for all the nodes which have this particular label, and look for the presence as true, right? So this label should be present on a node before it is marked as eligible for a deployment, right? A selectable label. And once you applied this, if you submit a pod manifest like this, right? So what it will do is it will look for two things. One, it will look for the selectable label, and it will also look for the device GPU, because you're also kind of asking the pod to kind of go only on the node where device GPU label is set, right? So these are the two conditions that it will look for, and once it will get a list of nodes which match these conditions, and then it will sort it based on priorities. Uh, okay, scheduling profiles. I think there's hardly anything which is mentioned here, but uh, you can have your own scheduling profiles. You can have multiple schedulers configured inside your cluster, present at the same time, right? You can have more than one schedulers, and you can ask your pod, right? Inside your pod, you can just provide a scheduler name config setting, right? In the pod definition, that for this particular deployment, I need this scheduler to be in action. So that's also a possibility. But again, these are all edge cases. For
Hmm.
80%, or I would say 90%, 95% of the times, you would not want to get into all of this. If you already found yourself in a position where you're dealing with this kind of stuff, you might already have committed a lot of engineering effort and bandwidth into it,
Right, right.
understanding how things are and
So
what
what
you
this
really want.
correct? One question thing that there was some of these policies, right? Not the scheduling policies there where you can decide the rack, the topology, right? Have you used topology anywhere in your environment?
Uh, I think we used topology not in a data center, but okay, I just used it once, and I believe the requirement was uh, it was something to do with the cost, right? So the data transfer between two availability zones
Uh-huh.
uh, is also significantly high if you have high volume, right? So this was in AWS, and data transfer between one A and one B was not desirable, right? And what
Hmm.
we wanted is if our load balancer controller is in one A, our pod should also be in one A, right? For
Hmm.
that. And that's where we had used a topology setting. I don't really recall what exactly was it called, but it was to kind of direct which particular AZ a pod should be deployed to, right? Based
Hmm.
on some condition, some prior condition. And I think
Okay.
it is similar to the rack example that you're mentioning, right?
Yeah,
In
yeah.
a way, AZ could be a rack
Correct, correct. You
to
mentioned
deploy.
that. Yeah, correct, correct.
Yeah. So what was your use case?
No, there's no use case. I just saw the documentation of that, but I have not got a use case of that. I'm not using myself yet in
Okay.
production.
Yeah, I mean these are all edge cases. I mean these are uh, like
No, I think in the on-prem setups, this makes much more sense actually on bare
huh,
metal stuff, where you can
yes.
want to make sure that you have two different tracks and power supplies and all those things are there, right? So, because you have to
Mm-hmm.
maintain all of them on your own,
Right,
right?
especially during
So,
upgrades and all, I think these strategies would be really helpful to know. Like, do a blue green of sorts, move everything from one rack to another rack, do some maintenance work, then kind of bring it back here.
correct, correct, correct. Yeah, you can put up that stuff. Yes.
Interesting. All right, I guess that kind of brings us to the end of this chapter. Uh, there was a lot of Golang code, and I was not prepared for the demo.
I
But I don't know.
know.
Maybe in the next session, probably we could do some demo of sorts.
Yeah, if Voldemar
But
says
again,
that,
Golang, I'm not sure if I'll be able to find time to sit and do that Golang
yeah,
thing.
yeah,
Maybe
that's
I'll do it
okay.
in Python because,
No
yeah,
worries, no, that's okay. I think maybe Voldemar can find time and he can show us. That's okay. I think
yeah.
as a part of this thing, we don't have to bother too much about it actually.
Hmm.
I mean, not, I'm not sure how many people are interested
So
also. Yeah, that's
maybe
why
maybe we can pick that book. Yeah, I forget the name. There's a very good popular book which
Cube
deals
Builder only,
around
right? Cube Builder only.
Cube Builder. Yes, yes,
Ah,
yes. Probably maybe when you pick that book up, we'll do a full hands-on session itself.
that will require somebody expert on Go and he has to commit it. I really can't do Go. At
Yeah, we'll find someone.
uh, okay, yeah. I'm going to stop the recording now and then.